Hello guys, in today's video I'm going to explain about types of chemical bond in chemistry. So this topic is types of chemical bonds. Okay, this is from the chapter chemical bonding and molecular structure, which is very important for class 11th and for the students who are preparing for NEET and engineering competitions. So what is chemical bond? First of all, we need to know what is chemical bond. Chemical bond is nothing but it is the attractive force that binds two atoms together in a molecule, right? In a molecule or in a molecular species, the attractive force that binds two atoms together is defined as chemical bond. So types of chemical bond. First type of chemical bond is ionic bond. So in this video I am going to give some examples in which ionic bond is present, in which covalent bond is present, or in which both ionic or covalent bond are present. Okay, so first type of bond is ionic bond, second type is covalent bond, and the third type of bond is called dative bond, right? So what is an ionic bond? Ionic bond is that chemical bond which is formed by the complete transfer of electrons from one atom, which is generally a metal, to another atom which is generally a non-metal. Actually, transfer of electrons results in the formation of a cation and anion, and that attractive force which is between a cation and anion, which are formed after the transfer of electrons, is called an ionic bond. So this is the attractive force between a cation and anion, in short. Okay, so this covalent bond is nothing but this is a chemical bond which results from the mutual sharing of electrons between two atoms which are generally non-metals. Okay, so by mutual sharing of electrons between two atoms which are generally non-metals, it is not necessarily non-metals, metals can also make covalent bond. Okay, dative bond is by donation of electrons between a donor and an acceptor. Okay, so let me give one example each of these bonds, and then let me solve some questions from related to this topic. Okay, so ionic bond, for example, I can take KCl, okay, or NaCl or Na sulfide. In this example, potassium has 2 8 8 1. I would the means potassium की valence electron is 1, while chlorine has 2 8 7, and number of valence electrons of chlorine is 7. So potassium needs to give one electron away to attain stability, means to acquire noble gas electronic configuration, while chlorine needs one atom to accept to maintain or to acquire noble gas electronic configuration, so that number of valence electrons is 8. So this chlorine has 7 valence electron, potassium nama pithokpa pamba, chlorine nama lopsanba pamba ko. means potassium say electron nama pitho ga harau jab hai tare chlorine lausal ga harau ko aduna se ama pithore ama lausale so potassium gives away one electron so it forms cation and the chlorine accepts one electron to form an anion so this can be written as chloride ion. So these are the valence electrons of chlorine. After accepting one electron from potassium, this becomes chloride ion. So it results in the formation of a cation and anion. So the attraction between these two oppositely charged ions is nothing but ionic bond, right? So let me give next example of covalent bond. This is the first example of ionic bond, and let me give the second example that is of covalent bond. Okay, so second example is of covalent bond. So let me give this example, water, which is very easy. Okay, so oxygen is the central atom, hydrogen ani oxygen the tabe sumaina atra ado hydrogen amagi valence electron kya ama sigiso ama oxygen ki valence electron kya no taruk ni ko aduna magi sina dots na represent tawrage ko dots aduga sigiso dots dot 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 natra valence electron taruk. Now hydrogen की duplet complete हो रहा है, hydrogen की duplet complete हो रहा है, oxygen की octet complete हो रहा है. So this results in the formation of two covalent bonds by mutual sharing of electrons between hydrogen and oxygen atom, and two lone pairs of electrons are left on oxygen atom. Okay, so these are covalent bonds. These two bonds are covalent bonds. Remember, covalent bonds are directional while ionic bonds are non-directional, which means this cation can be interacted to the anion. This anion can be interacted to the cation from any direction. Okay, so if I place this cation here, and if this is the anion, then if I place cation and anion in this direction, they will be attracted in this direction. So if I place the cation here and anion here, then this will be interacted in this direction from this direction. No direction is defined in ionic bonds. Okay, while covalent bonds are directional, which means the two hydrogen atoms must be directed towards the central atom at a fixed angle. Means in this case the angle is actually 104.5 degree in case of water. So I cannot draw water in this manner. This is the wrong structure of water. Okay, so direction is defined, means there is a fixed geometry and shape of covalent molecules, while there is no shape or geometry of what ionic compounds. Okay, so another example, the third example, let me give the third example of a dative bond, right? So dative bond is formed by the donation of electron. This is a special type of covalent bond in which both the electrons are coming from a single atom. For example, let me give the difference like this. A ga B ga gi marakta bond ama laidori or A ga B ga gi marakta ne ani si mi ani ne na khanbiro ba ko thabo ama tawnaba matamda tawnaba gi damakta, for example 100 rupees darkar laiba, for example ko 100 rupees darkar lai aduga, and that work, that task need to be done by two persons, A and B. Adu huzik 100 se ma A na 50 B na 50 puthoraga tawminareba, for example ko ado di manaba numbers of paisa se manaba paisa masing si puthonare ado di mutual sharing tare ko, and this bond will be a covalent bond. Now A ga B ga this will be covalent bond. Okay, and A ga B ga bond thabuk tu tawminadori ba ko 100 rupees ki darkar laiba, A na paisa laiba b na paisa leijadreba ko a na 100 mak puthoraga b na amta puthorakta bida but ani si pullaga thabak tu tawdaba gyan tare ko adu orgadi aduguma makhal ki bond du ko na kai ko in fact that bond ko weba abdi ani makki case ta paisa du ani makki sharing phange ni ko ne laudori ne ba ko ma yaujirga su ma ki sharing ma na pb ri haba donate to b ri ba a na ko gyan tare ko this is that bond or coordinate bond. Okay, so let me give the example of that bond here. Suppose ammonia, when ammonia reacts with HCl, we will get ammonium chloride. So in ammonium chloride there is a that bond. Let me explain how. Ammonia, in ammonia nitrogen is a central atom, so nitrogen has 5 valence electrons like this. So these 3 electrons makes 3 covalent bonds with hydrogen atom like this, okay, and if it is reacted with H plus from HCl, this nitrogen will give its electron to this hydrogen plus to form a dative bond. And remember there is another chloride ion, a chloride ion here. So nitrogen se sidaida hydrogen ahum sumaina laikhreba, which are covalent bonds because these bonds are formed by mutual sharing of electrons between hydrogen and nitrogen atoms, right? So these are covalent bonds, and this third bond, let me write with a different color. Where is my I have, okay, here is there. Okay, nitrogen se sidaida nitrogen siga hujik hydrogen plus siga mari suba bond nama say the same ko, but this bond is formed by the electrons of nitrogen only, while these bonds are formed by the electrons of nitrogen and hydrogen by mutual sharing, right? So these bonds, these 3 bonds, they are covalent bonds, while this bond is a dative bond. Okay, so nitrogen donates an electron to hydrogen, so this nitrogen becomes a cation here, and there is an anion, chloride ion here. So the interaction between this cation, the whole ammonium ion is positive now. So let me write this with a different color. This is the ammonium ion, which is the cation here, and this is the chloride ion, which is the anion here. Okay, so the interaction or the attraction between this whole cation and anion is nothing but this is ionic bond. So in fact this is dative bond, coordinate bond. These 3 bonds are covalent bonds, while this bond between ammonium ion and chloride ion is ionic bond. In fact, in ammonium chloride all the 3 types of bonds are present, right? I hope this is clear. If you have any problem, please comment on the comment section. Let me try to solve your problems, or let me clear your doubts in the next video. And now let me solve 1-2 questions which is based on the types of chemical bond, right? So the first question is you need to name the type or types of chemical bonds present in, for example, A. The first one is, for example, ozone, I can give, right? And second question is sodium hydroxide. Third question can be about sodium sulfide, and fourth question can be from ammonium. Let me give ammonium bromide. Okay, this is similar to ammonium chloride. Okay, this is very easy, I have already solved here. And The fifth one is C6H5Cl. This is chlorobenzene. Okay, and the sixth one, EF. Let me give the example of which one? Say N2O. Right? Let us solve these questions very quickly. Okay, now the first one is ozone. So you can comment on the comment section about the types of bonds present in ozone by pausing the video. Okay, now the answer A, ozone. In ozone, we need to draw the Lewis structure of ozone. In ozone, one oxygen atom will be the central atom, and these two will be the supposed terminal atoms. So using 2 electrons of this ozone, right, this oxygen, one bond is formed between these 2 oxygen atoms. Magi taret to dum lay hallo taruk tu sumaina dum lay hallo ko use the hallo kinova. This is the steps to draw Lewis structures. Okay, correctly. Similarly, magi electron ani use toraga bond nama sigi ani sigi maraktane same hallo sumaina. Let me draw this by cross. Okay, sigi mari use tore saida hujigai covalent bond ni dative bond ni high because this is just the steps. Okay, let me conclude after the structure is finished. Okay, so magi octet ani sigi sharing phangre octet complete ore ani sigi sharing phangre magi octet complete ore ko. Now sigi oxygen atom se magi octet complete oidri ani wali ama ani ahum mari manga taru ko. So either from this oxygen atom or this oxygen atom we can take out 2 electrons and form bonds with this oxygen atom like this. So now this oxygen, the central oxygen atom completes its octet now, so it is okay. This is the Lewis structure of ozone. So I can make this double bond here instead of here, and accordingly we will get 2 Lewis structures of ozone, right? So we need not to draw the second Lewis structure. This is enough for the question. So let us decide how many bonds are there, how many covalent bonds are there, is there any dative bond. So this bond is formed by the electrons of this oxygen atom only. This oxygen atom does not use any of its electron in making this bond, so therefore this is purely a dative bond. So this is a dative bond, right? And these 2 bonds are formed by the mutual sharing of 2 electrons of this oxygen and this oxygen, right? So I can just write like this. Sigi su ani use tore sigi su ani use tore ba natro aduna sigi star sim thamo sisi star don thok piro. Now this convert this star into dot, so which means somgyani, then these are bonds which are formed by mutual sharing ko. Aduna this is covalent bond, this is also covalent bond. So in ozone 2 types of bonds are present, covalent bond and dative bond. Number of covalent bonds can be counted. Number of dative bonds can also be counted, because dative bond is a special type of covalent bond, but ionic bonds cannot be counted. Okay. Okay. So this contains 2 types of bonds. One type is covalent bond, another type is dative bond, right? So second one is sodium hydroxide. Okay, sodium hydroxide. So in sodium hydroxide, let me draw its structure. Sodium has plus, O has minus. By accepting an electron from sodium, this is the electron accepted or taken out from sodium by oxygen, and this oxygen atom has its how many valence electron? 6, right? 1, 2, 3, 4, 5, and this is the 6th oxygen atom of oxygen, right? And this will be hydrogen, and its unpaired electron or valence electron is on 1. Hydrogen has only 1 unpaired electron. So this is an ionic bond and this is a covalent bond. So sodium hydroxide contains 2 types of bonds. one is ionic bond, another one is covalent bond. One covalent bond and ionic bond. Okay, so similarly I can just write the types of bonds present here without drawing all the structures, right? Because if I draw all the structures, and that would take more time and the video would be very long. So this sodium sulfide contains only ionic bond. Ammonium bromide, like I explained in ammonium chloride, it contains all the three types of bonds, which are covalent bond, dative bond, and ionic bond, right? So this is chlorobenzene or phenyl chloride, which contains only covalent bonds, not ionic bond, not dative bond. This contains only covalent bond, right? N2O, this is somewhat interesting compound. Let me draw the structure here quickly so that you have no any confusion. Out of these two nitrogen atoms and oxygen, which atom will be treated as nitrogen atom? So the central atom will be oxygen or one of the nitrogen atoms, right? This is the question. Let me draw its structure quickly. Means nitrogen, one of the nitrogen atoms will be acting as central atom. In the comment section, please write your opinions about why nitrogen will be acting as the central atom and why not oxygen atom, which is present only one atom, right? Okay, so this nitrogen atom, let me draw the quick structure of this N2O because it takes more time. Now this nitrogen has 5 valence electrons, so out of that 5 valence electron, 3 are here, and the 3 atoms electrons from this nitrogen atom, here 2 electrons will be left on this nitrogen atom, while the 2 electrons of this nitrogen atom will be used in making a dative bond between this nitrogen and this oxygen atom. This will be a dative bond, and the 6 valence electrons of oxygen atom are not used here, right? So 1 2 3 4 5 6. There is another Lewis structure of N2O other than this, but let me draw that structure in some other video. And so therefore in N2O 3 covalent bonds are present, while the 4th one is dative bond, right? So this contains covalent bond and number is 3 and 1 dative bond, right? Okay guys, for today let me stop this video here, and if you think that this video is helpful to you, please share this video to your friends as well, and please subscribe this video if you are new to the channel. And if you have any problem, if you have any topics on which you like me to make video on that particular topic, please write in the comment section. Thank you.